I'm using StratifiedKFold to split my data into 5 groups for cross-validation. This method is particularly useful because it ensures each group has roughly the same proportion of different classes in the data. Imagine dividing a deck of cards into 5 piles. Each pile has approximately the same proportion of hearts, spades, etc. I have 1,000 data points, with 900 belonging to one category, class 0, and 100 to another, class 1. This is an imbalanced dataset. I want to check which statements are correct about how my data is divided using StratifiedKFold. This statement is incorrect. While each fold ideally would have 200 samples, 1,000 samples, 5 folds, StratifiedKFold prioritizes maintaining a similar class distribution in each fold. This statement is correct. I'm maintaining the original 90-10 ratio. 90% of 200 is 180, and 10% is 20. This is correct. StratifiedKFold's main goal is to keep a similar ratio of classes in each fold as in the entire dataset. This statement is incorrect. StratifiedKFold aims for an asterisk approximate balance, not an exact one. It's challenging to achieve perfect balance, especially with smaller datasets. I'm using StratifiedKFold cross-validation, a technique that ensures each fold has roughly the same class distribution as the original dataset. This is important for handling imbalanced datasets like this one. I have 1,000 data points, where 900 belong to class 0 and 100 belong to class 1. This represents a significant imbalance. I'll split the data into 5 separate folds for cross-validation. This will give me a robust evaluation of my model's performance. In each of my 5 folds, I expect about 180 samples from class 0 and 20 samples from class 1. This maintains the original 90-10 ratio from the overall dataset. That's the beauty of StratifiedKFold. It keeps things balanced. This is a repetition of row 10's explanation. Each fold will preserve the original 90-10ths ratio. The approximate class distribution in each fold, around 180 examples of class 0 and 20 examples of class 1, is a direct result of using StratifiedKFold, a technique specifically designed to maintain class distribution during data splitting. See the explanation above. Same concept here, repeated for clarity. Again, I emphasize that each fold will approximately maintain the 90-10 ratio in class distribution. This is the final repetition, showing the consistent class distribution across all 5 folds. It's crucial to remember that this is an approximation, not an exact guarantee. This question asks you to identify the correct statements about how StratifiedKFold divides the data for cross-validation. I'll help you evaluate each statement. This statement is incorrect. While the total number of samples is 1,000 and there are 5 folds, StratifiedKFold prioritizes maintaining the class proportions, 90% class 0 and 10% class 1, in each fold. It doesn't just divide the data equally. This is correct. This is exactly what StratifiedKFold aims for. Because there are 900 samples from class 0 and 100 from class 1, each fold should have roughly 90% of its samples from class 0 and 10% from class 1. That translates to about 180 from class 0 and 20 from class 1 in each of the 5 folds, since 200 is 1/5 of 1,000. This is also correct. StratifiedKFold preserves the class ratios across the folds, which is why option B is true. It aims to make sure each fold is a mini representation of the whole dataset. Incorrect. StratifiedKFold tries its best to maintain similar class proportions, but it doesn't guarantee an exact match. Because there is a limited number of samples, perfectly even distribution isn't always feasible. It's about getting a close approximation, not perfect equality. I'm using StratifiedKFold because I have an imbalanced dataset. This technique ensures that the class proportions in each fold are similar to the overall dataset, preventing bias during cross-validation. Think of it like making sure each team in a sports league has a similar mix of skilled and less skilled players, so the games are fair. I have a total of 1000 data points, which are labeled into two classes. 900 fall under class 0, and 100 fall under class 1. This is a highly imbalanced dataset, meaning one class is significantly more frequent than the other. I will split my data into 5 folds using StratifiedKFold. Each fold will serve as a test set once, with the remaining folds being the training set. Because of the StratifiedKFold technique, I expect each fold to contain roughly 180 samples from class 0 and 20 samples from class 1. This maintains the original 90-to-10 ratio. Think 90% of 200 is 180, and 10% of 200 is 20. The key is that StratifiedKFold tries to preserve the class ratio, 90-to-10 in this case, in each fold. It's approximate, because you can't always perfectly split uneven numbers. For example, I'll have an approximately 90-to-10 ratio in each of the 5 folds for a fair comparison. I'm using a technique called StratifiedKFold cross-validation. This means I'll split my data into 5 groups, folds, making sure each group has roughly the same mix of class 0 and class 1 samples as the original dataset. It's like making sure each slice of a pizza has a similar proportion of pepperoni and mushrooms, not just any random assortment. This is especially important because my dataset is highly imbalanced. My dataset has 1000 samples in total. A big chunk, 900 samples, belongs to class 0, while the remaining 100 samples belong to class 1. That's a serious imbalance, a 90-to-10 ratio. In each of my 5 folds, I expect to see approximately 180 samples from class 0 and 20 samples from class 1. I'm maintaining the original 90-to-10 ratio in each group. That's what StratifiedKFold aims for, to keep that proportion throughout each fold. I'm making sure each fold mirrors the original dataset's class distribution. The 90-to-10 ratio of class 0 to class 1 is approximately maintained in each of the 5 folds. That's the whole point of using StratifiedKFold, to avoid biased results caused by the imbalance in my data. Think of it like this. I want a fair representation of both classes in each fold, just like a fair election. I have a dataset with 1000 samples in total. This is the starting point for my StratifiedKFold cross-validation. Out of the 1000 samples, 900 belong to class 0. This represents a significant majority of my data. The remaining 100 samples are from class 1. This is a much smaller class, leading to an imbalanced dataset. I need to ensure that my cross-validation technique doesn't bias my model's evaluation in favor of the majority class. I'll use StratifiedKFold cross-validation. StratifiedKFold is a technique where I split my dataset into 5 folds, ensuring each fold has roughly the same proportion of samples from each class, class 0 and class 1, as the original dataset. This addresses the class imbalance issue. Since I'm performing 5-fold cross-validation on 1000 samples, each fold will contain approximately 200 samples, 1000 fifths equals 200. To maintain the 90-to-10 ratio from the original dataset, each fold will have roughly 180 samples from class 0, 90% of 200, and 20 samples from class 1, 10% of 200. This is the crucial aspect of StratifiedKFold. It preserves the class distribution during the splitting process.